I'm Gabe Hedges. I'm the team webpage manager and organizer.
I'm Andrew Coyle. I'm the team programmer and track manager.
I'm Mark Holzer, and I'm the team AEV designer and builder.
My name is Eugene and I am the videographer at SolidWorks Smallwood.
We are AEV.
The motivation for the AEV project came from the Benny railplane. The Benny railplane was a former rail transport invented by George Benny, which moved along an overhead rail by the way of propellers. It was intended to run above conventional railways, separating faster passenger traffic from slower freight traffic. In spite of interest from around the world, Benny could not obtain the financial backing he required to develop his revolutionary transport system. By 1937, Benny was bankrupt. He had financed almost the entire venture by himself. The Benny railplane was a failed venture, but serves as a useful tool for budding engineers to begin honing their skills.
As a team, we were given an AEV kit with all the necessary materials to design a railplane vehicle to complete the MCR objective. The main goal of the MCR objective was for the vehicle to be able to pick up cargo while proceeding through a gate multiple times and bring it back to the beginning.
The first design was Eugene's design. It was inspired by the Stingray with the purpose of being aerodynamic and stable. Mark's design was a side-by-side propeller system with the intention of equal weight distribution. Gabe's design took a more narrow approach with the hopes of being more aerodynamic and maneuverable. Andrew's design utilized a pull system with the hopes that it would conserve more energy.
The team used a scoring matrix to rate the 4 initial designs, and after review, Mark's designs prevailed as the most practical design.
Moving on in the design process, the team took the idea behind Mark's design and flipped it in hopes for increased efficiency. After multiple tests, the result was catastrophic. It was physically impossible to balance this AEV design.
Design B was the team's hope of saving this project. It maintained the one on top of the other propeller system, but used a different arm and a wedge structure to improve the balance. After multiple tests, it was clear that the team was going to move forward with this design based on balance and performance.
The final design utilized an inverted T-shape with a push system and dual wings so the team would have room to maneuver components to balance the AEV. This priority was paramount to avoid more critical mission failures.
The team was able to complete the MCR during the final testing, barring a few setbacks due to sensor error. The sensor mark error caused the AEV to miss a few gates and ram into the final landing zone. Overall, the objectives were met.
Let's talk about the overall evaluation. So, what were some of the obstacles the team faced, and how did they overcome those obstacles?
Well, one of the obstacles that the team faced was the sensor mark error, which was 11 compared to the average of 2. This definitely contributed to inconsistent runs along the track.
That was good. When you looked at the AEV, the early, designs of it, it had trouble with balance. And whenever it cut a corner, the AEV was unstable and, it was swinging back and forth afterwards. But you see, the team's final design was able to balance correctly and it overcame those, troubles and issues. And in the end, it was able to allow it to travel across the track, pick up the R2-D2 and bring it back home.
That's good. So they completed the mission safely.
Yes.
Good. That's what we want. Overall, the team worked very well together and had a lot of fun with the project, and they just like to thank all of the instructors and TAs who helped them out with completing this mission successfully.
Tonight.